Daryl's being mean.
I have an envelope.
Just joke out today.
You may start.
I had a good morning today.
Oh, that's good.
Hi, welcome to Math 1300. This is Nunez Community College. Today's lesson, we will be doing section 2.3, which is linear functions and slope. First thing we have to talk about is slope. What exactly is slope? Slope is when we look at a line or a line segment and we measure the slant of the line, the slant of the line. So we have slopes. Here's my line, and we're measuring how fast it goes up or down, okay, called a slant of the line. Slope is measured as an m. That's the designated variable we have for it, and it's usually known as the rise over the run. The rise over the run. The rise meaning how fast or slow it goes up, and the run meaning across. Now, the types of slope that we have, if from left to right, we always read it from left to right. If from left to right we're going uphill, this is known as a positive slope. Okay? If from left to right, the line or line segment is going downhill, that's known as a negative slope. If from left to right, the line is not rising or falling, it's just going horizontal, this could be called zero slope or no slope. And finally, if we have a vertical line going straight up and down, then this is known as undefined slope. So these are the four types of slopes that we're going to have. Now what we're going to do with this slope symbol is we're going to measure the rise and measure the run, therefore giving us a number so we know exactly how fast or how slow it's rising or falling. The slope is going to deal with 2 points that are on the line or the line segment, where we're going to have point 1 with an x and a y. Since that's point 1, this will be x1, y1. And this will be point 2, and we'll have another x and a y. So this will be x2 and a y2. So to measure the rise of the line segment, we deal with the y's. The y's deals with the rise. And to deal with the run going across, that is the x's, or the x coordinate of the ordered pairs. So the slope formula is the difference in the y's, meaning y2 minus y1, y2 minus y1, over the difference in the x's, which is x2 minus x1. x2 minus x1. So that's the formula we're going to use when asked to find the slope. And in example number 1, it's going to read, example number 1 will read, find the slope of the line passing through the 2 points P, -1, 2, and Q, our points are P and Q, Q, 7, 8, 7, 8. So find the slope of the line passing through these 2 points. It doesn't have to be drawn for you. All we need is the coordinates of the points. So it's going to be slope m equals y2 minus y1 over x2 minus x1. y2, this will be my second point because it's the second point that I see. So this will be my y2, which is 8, minus y1, which is 2, over x2, which is 7, minus x1, which is minus a -1. We'll call that plus 1. Minus a negative would be adding. When we subtract, we'll have what? 6 over 8 8 minus 2 is 6, 7 plus 1 is 8. And 6/8 reduces because we can what? Divide both of them by 2 to 3/4. To 3/4. And 3/4 means that we would, 3/4 means that we would go up 3 units and we would go to the right or over 4 units. So up 3 units for every 4 units that it goes across. Now, how can we change that? The only thing we're going to do is we're going to put in things like fractions, change it as different numbers, but it's going to be the same formula, same technique every single time. Example number 2 has find the slope of the line passing through the pair of points P negative 1/3, comma, 1/5, and Q, which is going to be 2/3 and negative 9/5. 2/3 and negative 9/5. So when we set this up, we have our slope. It's equal to negative 9/5, which is y2, minus y1, which is minus 1/5, over x2, 2/3, minus a negative is plus 1/3. So when we're adding and subtracting fractions, we have to get a common denominator. They already have common denominators because on the top we have 5 as our denominator, on the bottom we have 3. So this will be negative 9/5 minus 1/5 is negative 10/5 over 2/3 plus 1/3, which is 3/3. 3/3 would be 1 on the bottom, and negative 10/5 would be negative 2 on top. So therefore, in this case, negative 2 over 1 means we go down 2 units, and we go to the right 1 unit. So in this one, we go down 2 and to the right 1. Okay, suppose they tell us to find the slope of a line which is x minus 9 equals 0. X minus 9 equals 0. Or find the slope of 3y equals 9. 3y equals 9. So in the first one, we're going to what? Isolate the x. I got x equals 9. X equals 9. How can we find the slope of x equals 9? Well, first of all, I would think that we need to be able to, because there's no rise in rise over run, right? So what I would do is I would try to graph it so we can see better on what's going on. For x equals 9, we'll go over here and we'll find 9. Well, x equals 9. And x equals 9 right here on the number line on the x-axis. But is that the only place that x equals 9? The answer is no. If I go up 1, does x equal 9 right here? Yes. This coordinate is what? 9 comma 1. This coordinate is 9 comma 0. If I go up 5, this would be what? 9 comma 5. If I go down 3, this would be what? 9 comma negative 3. All of these points, x equals 9. So x equals 9 would be a vertical line through the number 9 on the x-axis. For the other one, we have 3y equals 9. In order to solve for y, I'm going to divide by 3, and I come up with y equals 3. Well, just like the vertical line, x equals 9, if I have y equals, it's going to be a horizontal line through the y equals that number. So this would be y equals 3. Again, 0 comma 3, anything comma 3, so y equals 3 at all of those points. So again, x equals would be a vertical line, Y equals would be a horizontal line. Okay. And now we are on lines that are parallel. Parallel lines. It's a term that we use when what? When lines do not cross. Parallel lines means lines that do not cross. Parallel lines, lines that do not cross. So if I wanted to draw a set of parallel lines, I would draw a coordinate plane, and I would draw two lines that don't touch. We'll call this line 1 and this one line 2. Now, there's got to be something in common with these lines, and there are. Lines that are parallel have the same slopes. So our slopes have to be the same so that they go up the same amount, over the same amount, up the same amount, over the same amount, and they don't cross. So if the first one has a slope of 1/2, for instance, the second one must also have the slope of 1/2 for them to be considered parallel. Now, another thing that we want to look at is the symbol. The two lines, sort of like absolute values almost, or a number 11, this is the symbol for parallel lines. So if we have that number 11 there, it means parallel lines. The last one that we have is going to be perpendicular lines. Perpendicular lines. I'll put this to the side so you can see both of them together. Perpendicular. Well, perpendicular lines do cross. Perpendicular lines do cross. They cross at 90-degree angles. Two lines that cross at 90-degree angles. Two lines that cross at 90-degree angles. So if I have line 1 facing up, the one that crosses it, or the perpendicular line, would cross, making a 90-degree angle. So this would be line 2 here. They make 90-degree angles. Now, obviously, they can't have the same slopes because they cross. So the slopes for perpendicular lines, are opposite, as in opposite in sign. If one's positive, the other one's negative. Opposite reciprocals. Reciprocals means to flip. So if the slope on this line is 2/3, then the slope on the line perpendicular to it is negative, because that's positive. This will be negative. They're opposites, and we flip it 3/2. Negative 3/2. These would be perpendicular lines. Also, the symbol for perpendicular is an upside down T. That means perpendicular. Okay, that means perpendicular. So the 11 means parallel, the upside down T means perpendicular. And to finish this section off, we're going to take some slopes and we're going to write down the slope of the line that would be parallel to that line and the slope of the line that would be perpendicular to that line. So I'm going to have a slope, okay? And let's say we have the slope 2/5. Let's say we have the slope 5, negative 1/4, and 5/7. We want to find the slope of the line parallel, and we want to find the slope of the line perpendicular to these particular lines. So on the first one, if it's parallel to this first line, the slopes would be the same, 2/5. If it's perpendicular to this line, it's going to be the opposite, so it's going to be negative, and flip, reciprocal, so 5/2. For this one here, it'd be parallel, would be 5. Perpendicular would be negative. If I flip it, it would be 1/5. For this one here, parallel would be negative 1/4, and perpendicular would be positive 4. And then on the last one, if we have 5/7, parallel would be 5/7, perpendicular would be negative 7/5. And this concludes section 2.3 of Math 1300. I'll see you at the next one.